All right, so welcome to this week's Unikernel application spotlight. This one's coming out a little bit early this week. It's 4th of July here in the U.S. So I'm just gonna get this one. We have a unique one this week. This one is Orthanc, and basically it's a lightweight DICOM server. So DICOM, however you pronounce it. But basically, it's a server to deal with various images that you might get taken at the doctors. So like CT scans or MRIs or anything like that. And of course, they don't just take like one image; they take a set of images. One day they come back the next week, take another set of images, and then it's both a file format and it's also kind of a network protocol as well. And the reasoning behind it is because these images, they're not just images, they have a metadata layer to it, so describing a lot of data about the patient in general. And then the network stuff is because there's all these like complex machines from like companies like Siemens and so forth that are actually doing the imaging, and then they get shot like everywhere, right? So you know how many hospitals are in the world? A lot. You need a way to kind of transfer these things and secure them and all that sort of stuff. So on the security note, DICOM servers, PAC servers, these are all what CISA here in the U.S. Would list under a critical infrastructure umbrella. So critical infrastructure is like stuff that you really don't want to get hacked um, because bad things happen. Well, the problem is these things get hacked all the time. Ransomware affects hospitals disproportionately by quite a lot. You can imagine a lot of software they use, a lot of GUI, point and click, Windows type of software. And one answer would be like, well, you can just use Orthanc. And that's true, you can. But, that's still in many cases going to be running under Linux. So, God forbid you find a vulnerability in this, you still have a full blown Linux server that you can attack. Um, but if you run it as like a Nanos Unikernel, well, all of a sudden you can't just spawn a shell and start encrypting the files and doing all this other crap that you could on Linux. And so I was pleased that this kind of just worked out of the box in Nanos, and that's what we're going to look today. So, just first off, I don't claim to know too much about this ecosystem at all. so, this is, I think it's quite a complex ecosystem. Complex in terms of like, there's a lot of various things in it. And then, over time, even this piece of software started out in 2012, right? Or maybe even before. But the protocols and so forth have been around for a lot longer. And even in this software ecosystem, there's a lot of like plugins and add-ons and just all sorts of stuff. So it's very extensive in that manner. Obviously, we're not going to get to all that, but I just want to point that out. And when we're talking about DICOM, again, this is a lot more complex in terms of just like the abstractions that exist. And we're not really going to get too much into it. But as I mentioned, we have both a file format and a network format. And it's not just images, there's data in the images. And then there's the concept of like how these things have a lifetime and, how they kind of encompass each other. This little diagram does a decent job. You have your patient, you have these sets of studies, which contains sets of series, and the series contains instances. And then, the metadata itself obviously can get a lot more complex. But yeah, it kind of goes on, right? This is where they actually host. They're not on GitHub. They're on this Mercurial instance. Um, so as you can see, it's fairly active. even as I'm writing this, they're making changes as of today. So I don't know why it keeps popping that up. I'm just gonna. Okay, and then it uses this library, DCMTK, and so I guess this does a lot of like kind of the actual, screwing around with the actual files and so forth, and I guess even some of the network component it does. But this is the kind of the main library that's used. You can grab the package here, and let's go ahead and check it out. So we're gonna load it up. Pop in over here. All right, so we have it loaded up, and so this is written in C++. It's single binary. It just works, spins up immediately, yada yada. That's all good. So this is what we're greeted with when we log in. It says, "Hey, you're insecure," yada yada. I'm doing a basic configuration after looking at the config for about 5 minutes. Obviously, your mileage might vary, including remote access, authentication, all this good stuff. But let's go ahead and upload a file, send it through its lifecycle. So select the file. I got a sample DICOM file here. You can find samples all over line. Obviously, if you're actually going to go through the motions of working through this, in a real setting, probably have other things. So we gotta go ahead and upload it. It says done. I believe it's done. Let's click back. So we can go to all patients. We can go to all studies. I'm just gonna click on all studies. So Rubo demo, study date of 1994, 95. And so as you can see, we click from patient to study, and then we're into our series, and then we have preview series. We can click into an instance. So this is an actual instance here, and we can go ahead and preview it. And so I don't even know what I am looking at here, but there's a few pictures, I guess. Oh, so you can kind of see whatever this is. I don't know what the hell I'm looking at, but if you click enough fast, you can kind of see it move, right? Interesting. So when we talk about metadata, this is the type of metadata that's getting included in here, right? And we can even see the JSON here. And so if you're more of a data person, we can extract that out and kind of get everything. So, there's a cardio related stuff here, and all sorts of stuff, you can send it, you can download it, you can do all sorts of stuff, and obviously all the various plugins and stuff. So it's pretty basic, right? Let's go ahead and look at what the package looks like. There wasn't any tricks, but I think there's so it's about 40 meg all in. Let's see. Oh, so yeah, I wanted to show you the Orthanc JSON. So this is the actual config file. I gave it a base volume of 100 megs. Your mileage varies. If you're going to store a lot of these pictures and so forth, it might be wise to set up an external volume. So, depending on where you're at, you can run that volume locally, or if you're in the cloud, you can, just attach a volume and just have it there. But after it gets over a gig or two, I would definitely use an external volume. So we can do sysroot and then Orthanc JSON. So this is our JSON config file, and that's really interesting. I just noticed that there's comments in this. Interesting. I didn't see this before, but the only real thing that I changed here was the remote. Yeah, this is the only thing that I actually changed, was remote access allowed, because it's bound to like localhost or whatever. You can change this. You can do kind of whatever needs to be done here. As you can see, there's a lot of various configs that you can kind of put in here. I'm gonna have to, as a follow-up task, wonder how they have these comments in here. But yeah, as you can see, it's pretty infinitely configurable. And then, you know, the rest of this, I don't think there's, I added the local time. It wanted that, and that's about it. So, yeah. Anyways, this was the Orthanc, you know, DICOM server, and it's now running as a Nanos Unikernel. So, you know, if you're like an MSP, you're working with some hospitals, and you want some like highly secure setups, you know, this might be an option. All right, till next week.